I'd love to know what you think about this, because you are the you're the initial point of that, where you make the thing and then we decide, you know, how we use it. But you are making the thing. So how do you think about that as you're making this happen?
Yeah, I mean, there's just so many layers to that question. Um, I think, like I said, a lot of us researchers who work in the corporate world wear two hats. One is the hat of the open ecosystem researcher, and this is the hat that believes in open source, believes in publishing, and being very transparent about publications, all the way down to what data sets are used, what methodologies are used, how the comparison with different baselines is done, and even down to how compute intensive the solution is. Like, is it going to be sort of sustainable in terms of the computing? And I got to say, like, I've seen at Intel very, very strong emphasis on these questions early on. In fact, there's a whole group of people that think about responsible AI very, very deeply. And even though we are very open source friendly, I mean, I would say 80% plus of the things that we develop, we open source in my lab particularly, and many other labs within Intel labs that work on AI. We're very open source friendly, but that also means that we are very cognizant of the responsibility that comes with releasing something to the public. Open source already takes away a lot of the friction because you can really go inside the code. But we also are very careful about what data is used to train our machine learning models. We make it very transparent in terms of the sort of the compute requirements, the memory requirements, and such. There will always be a niche set of things that don't make sense to open source, because this might be very valuable company IP that is directly responsible for generating massive amounts of revenue and things like that, and we have to take that call sort of project by project. But I would say the vast majority of the things that we do is open source. You also have to think, I mean, there's another way of enabling the open ecosystem, which may not be open source, but sort of the GPT model, where you still provide APIs to sort of do fine tuning for your corporate data and things like that. Again, there things are a little bit of a slippery slope, because transparency is a very important thing, and you're already seeing this. I mean, to the point of derivative works and things like that. The question that you asked, people are finding out secondhand that their data might have been scraped. They're finding out by generating text that looks exactly like the text that they've written. And that's how they're finding out that their data has been used. And so I think for going forward, products like GPT or derivatives of GPT or whatever comes in the future really need to be open, at least about the data sources that they've used. And because this directly means whether you pay a royalty at that level to an author or a creator, right? So that is extremely important according to me, and something that I'm glad that sort of GPT brought that attention back to sort of data ownership. And there's of course model ownership, which is a whole different question, whether you make the model open source or you make the model closed source. But at the very least, I can understand sort of a lot of companies desire to make the model closed source because you want to control revenue and things like that. But I feel there's a point where things like data provenance is non-negotiable, because then you open up from the company's perspective, you open up yourself to legal risk, and from the consumer's perspective, you don't know where on the plagiarism spectrum the content that you're consuming, where that lies. You cannot even make a definitive decision about that if you didn't know what data was consumed to begin with. So I think these are very, very important sort of policy questions that will, I'm sure, keep us busy for many, many years.
I asked this question for the people who just stumble upon, the podcast, or, sort of trying to figure out what they're going to do in their sort of in their careers, and see something like this and think, okay, what if I wanted to be sort of in the position of a researcher, but in this very particular niche, but at Intel or any other company. So I think I'll ask a very rudimentary question, which is, what do you think the best way to get started in this field is now? Where do you think people should be really focusing on as they complete, their high school or are trying maybe to get into their masters, sort of trying to get to that next tier of accreditation or interest?
That's a great question. Yeah, I think the answer depends on where in their career path or their academic path people are. I think if you're talking about students that are in maybe high school or even these days I've seen blogs from 8th and 9th graders writing about deep learning. So I'm not surprised anymore that they're thinking, but it's great that they're thinking. So I think if you're at that level, where you're at high school level, I think math. Forget about the buzzwords. I think my biggest advice would be stop reading, social media posts on AI. Stop reading all the book, either the doom and gloom or the other end of the spectrum where this is the best thing since sliced bread. Tune that out. Because at the end of the day, the people who build these systems are fundamentally mathematicians, logicians, computer scientists. So I think the focus on the fundamental sciences and mathematics is what is going to drive this field forward. And this generation that are currently high schoolers or at that sort of high school to just graduating into college, that is the perfect time to put your head down and just do the math, so to speak. I think if you're sort of an early stage career person who's just maybe graduating from maybe a 4-year undergrad course or things like that, I would strongly suggest going into grad school, even if it's for a couple of years, and take a few courses and maybe even do a thesis on machine learning or AI projects. I think it keeps if you enter the corporate world right away as a corporate researcher, there are a lot more expectations from the industry to start producing products. And I think that takes away from the focus on really, developing the technical skills you need to solve this. So my advice would be, if you're a high school student or in that sort of period, just do math, linear algebra, matrices. It's funny, my high school teacher back in, I think, 10th grade actually told me, I used to ask this question, like, why are we doing all this mathematics stuff? Where am I going to use it in my life? And she said, I still remember, there's a true story. She said, the one thing you should take away is matrices. And I don't think she even knew what role matrices would play. And it literally pays my salary to. So I don't know what the equivalent of matrices for today's kids are, but I would say, just do math. And then if you've gone through that rigorous training of mathematics in high school or first year undergrad, and then go into a deeper study into maybe a 2-year master's program, you are really set to be a solid, respected sort of researcher who can actually deep dive and sort of disambiguate between all these, flashy terms like LLMs and general intelligence, and take that out of your head. Just focus on them, because math's gonna move this field forward.
Well, if people wanted to move forward and find you, where would they be able to do so?
Oh, just I'm not much of a social media person. I think I'm just on LinkedIn, so they can find me on LinkedIn, send me a message. I'd be happy to chat with anyone and carry on a conversation.
Well, thank you so much for being on the program and being on the podcast, and basically just like teaching us about what you do and all the research you're doing. I'm sure there's lots of interesting things that are going to come out of your lab, and I'm looking forward to every single one of those things. And just thank you for teaching us about how chips can be improved, and some of the protein stuff you're doing. I think those things are really, really cool. They're really, really interesting, and I'm looking forward to seeing them in the market as you're working towards.
Absolutely. Thank you, Chris. This was super fun for me.
Good. Thank you.
If you like what you saw, take a look at the description. You'll see segments. You'll see the full podcast. Go take a look. Please go listen. Don't forget to like and subscribe. Thank you for watching. We'll see you later.